Now let's apply the analysis plan to the example that we started in a previous video. You already saw this research question where we were interested about the relationship between satisfaction and discount. And here's our null and alternative hypotheses. And step one would be to assess whether the level of measurement of the two variables is appropriate for correlation analysis. So they either have to be both ratio or both interval or one of each. And in this case, the satisfaction in a 0 to 100% rating scale, well, that would make it ratio. And then discount in dollars, that would be ratio also. So we're good to go there. Let me type in ratio. Now let's look at step two. We're going to check for outliers in each variable. Now there are a lot of variables, lots of data points there. And so I only included the 6 on here, top 6, bottom 6. Only the 6 lowest and 6 highest z-scores shown for each variable. And remember that the cutoff is anything over 3.29, positive or negative. And when you look at these numbers, there are no values that go over that. And so we have no outliers in this data set. Step number 3 is to check the skewness in each variable. If skewness is greater than the absolute value of 1, then we would have to check residuals for normality. We would have to take that extra step. But looking at skewness in each variable, they're both less than 1, so we're good to go there. Step 4 is to check for linearity. To do that, the first step is to create a scatter plot. And regarding this scatter plot here at the top, so this scatter plot contains 96 dots, one for each person in the survey. So yeah, each dot there represents a person. So this one got this much of a discount and was not very satisfied. And then what we do is we then put a lowest line on there. I'll put this note here and then I'll tell you more about that. So regression line has to be straight. Now, for those of you familiar with regression, you might say, oh yeah, well, that's a regression line. Well, no, a lowest line is not a regression line. What we have here is it's a lowest line is fitted to the data with no linearity requirement. So it can kind of do small wiggles. But if you look at that, that's really close to a straight line, right? Oh, one more thing I wanted to say about the lowest line is that it's the weighted average of all the points. So yeah, just kind of go with it, right? That's why we have software to do this stuff for us. All we have to do is look at it and say, yep, that lowest line is straight-ish, right? So yeah, that's the next step there. If the lowest line is straight or straight-ish, the relationship is linear. Small wiggles in the lowest line, like the one above here, are okay. They can be ignored, and the relationship be treated as linear. Noticeable dips or curves suggest a non-linear relationship, kind of like what we see here. So that's definitely not a linear relationship. That would be an example of a non-linear lowest line. So now that we've established that this is a linear relationship, let's go to step number 5, and actually run the correlation analysis, and the output will look something like this. And I've mapped out from A to E what each mean. And so let me type that here. This is what we call the Pearson's product moment correlation. So that's just another way of calling Pearson's R. So just don't be thrown by that name, product moment. Okay, first one here. A tells us what variables are being correlated. So in this case, it's satisfaction and discount. And then B is the next line. This gives us the T statistic using that formula you saw earlier. And then it gives us the p-value based on the T statistic and the degrees of freedom. And in this case, the p-value is really small. So yeah, that would tell us whether a rho in a population is equal to 0. And then the next one would be the alternative hypothesis for this test. So the alternative hypothesis would be that a true correlation is not equal to 0. And then the next one is D, that's the confidence interval. So looking at this confidence interval, we could be confident in saying that we are 95% certain that the correlation in the population is between 0.23 and 0.57. And then lastly, E, this gives us the correlation in the sample. Okay, so at this point, this is where I would recommend that you pause the video, take a minute, and reflect on this a little bit. And then when you're ready, let's go to step number 6. Okay, hey, you're back. So let's move on to step number 6. Our next thing we got to do is assess the effect size for correlation. And this is assessed by the coefficient of determination R square. I guess somebody decided coefficient of determination sounded cool, so here we are. And yeah, as you can see there, it's just squaring this R that we were given. It's often described as the percentage of variance explained. For example, variable A explains X percent of the variance or variation in variable B, or variable B explains X percent of the variance in variable A. And if I know the value of variable A, how well can I guess the value for variable B? Well, we can kind of do this thought exercise. So if R squared were equal to 1, which doesn't really happen, but let's just say it gets really close to 1, then I'm going to know if I know the person's satisfaction level, then I can perfectly guess the discount the person received. And then conversely, if I know the discount, I can perfectly guess the person's satisfaction level. Now, in our example, if we square the R squared, we get 0.1736. So that translates to 17.36% of the variation in dealer satisfaction is explained by the discount the buyer negotiated. So that makes sense, right? If you negotiated a good price, that'll give you some level of satisfaction. But there are a lot of unexplained variance left, right? And we can figure out what that unexplained variance is by subtracting 17.36% in this example from 1. So 1 minus 0.1736, that's what? 82.64%. So that's still a lot of variance. And so what things do you think might account for unexplained variance? Well, think about the last time you bought a car. Lots of other things would affect how satisfied you were, right? It could be the car quality. I know one time when I bought a truck, when they went to deliver it to me or present it to me, there was a huge scratch on it. And so, yeah, that didn't make me happy, right? And then the different options you have as far as what you could add with your purchase. I know, yeah, it sounds like I don't have a lot of luck in buying vehicles, but yeah, another time I bought a vehicle and it didn't come with floor mats, which I was expecting to get. So that was kind of weird. And then financing, certainly if you got 0% financing, right, or a good financing rate, then that would explain that would have an effect on your satisfaction level. The process time, they don't make it easy, right? Like, even though you tell them you're really busy, you pretty much should just take the whole day off or the whole evening off if you want to buy a car. And then the salesperson, their personality, that certainly could affect the whole interaction. And then the dealership qualities, maybe it was filthy or just lots of different factors. Like, we could just say etc. And so yeah, that makes sense that the other 80, about 83% would be all these different things. All right, last point in this video is step number 7, the last step. Interpret the correlation analysis results. And when presenting your results, these are the things to include in there: the direction of the association and the strength of the association, and then name both variables in your interpretation. So here's an example right here using what we've been working with. Size of discount from sticker price that a buyer was able to negotiate from a car dealer is positively associated with satisfaction with a new car dealer. In other words, the larger the discount negotiated, the higher the satisfaction. So this first bullet point explains the direction of the relationship. It's positive, positively associated. Discount explains 17% of the variation in satisfaction across new buyers. So the second bullet point describes the strength of the association. So that's that R squared. Other factors not included in the analysis are also important contributors to buyer satisfaction because, right, there's still 83% unexplained. So the third bullet point reminds the reader that other variables besides discount are relevant to buyer satisfaction. Now, you would normally report all of these together in one paragraph, but just for education purposes, to highlight the important elements, we presented it this way. All right, that's it for this video. In the next one, let's talk about this next topic.